Hi, guys. So I wanted to give you a little bit of an introduction to field theory today, because this is going to be kind of the big idea of this unit. We're going to be using this to try to explain that phenomena that we saw in our video early on. Now, you should already be familiar with one theory. Remember, a theory is an explanation of why something does what it does. We've already been introduced to one theory of gravitation, which is that idea of the relativity and Einstein's explanation of the folding of space-time, right? That a mass causes space-time to be bent, which causes everything to kind of fall towards it. That sometimes is a little bit rough on our brain because, we're trying to imagine that folding in 3 dimensions. We can model it in 2 dimensions, like you saw in the previous video with the big spandex table and the masses in the middle. So you're able to kind of visualize it in 2 dimensions, but it's a little weird when we start talking about 3 dimensions or even 4 dimensions when we add in time. So I wanted to introduce to you another theory. Some of you watched the video on gravitons, and whether you did that or not, it's not important. It's just another idea, another theory, trying to explain why gravity works the way that it works. All right. The other theory that we're going to talk about and that we're going to address during the rest of this unit is what we call field theory. All right. Now, field theory basically says that any object can exert what is called a field. It creates its own field of, based off of its properties. All right. Now, field theory can explain any of the forces that are not contact forces, right? Back in our first semester, we talked about Newtonian dynamics, and we talked about contact forces, and we talked about non-contact forces. But we said there's only very few types of non-contact forces that actually exist. And we tried to get rid of a lot of those, the force of the throw or the force of the kick that happened, a long time ago. Those forces don't happen anymore. It's only the forces that are acting right now. And we talked in passing of 3 non-contact forces that we need to be aware of. We talked about gravity. All right. We talked about the electric force, and we talked about the magnetic force. All right. Now, all 3 of these can be explained using what we call field theory. And I've kind of got some drawings up here to kind of help you out as we look at this idea of field theory. So gravitational field theory says that if I have a mass, that mass creates a field around it, and that anything placed in that field will be affected by the mass itself. All right. Now, gravitation depends on only the mass. Nothing else matters. Okay. So gravitation depends on the mass. So if I take another mass right here, it's a mass because it's got an M on it. We're going to put that mass inside this field. And if I put that mass there, then it's going to follow the direction of the field. And so what you're seeing here is that all the field lines point inwards. And as far as we know, with positive mass, we don't know about anything with negative mass yet, though it's, hypothesized and theorized. But with positive mass, it will always move in towards the other one. It'll always be attracted. And so we can see the field. I've drawn in these arrows, these vectors here are the field lines. And so it represents how strong the field is at that point. Now, you'll notice that as I'm closer to it, those field lines are closer together, which goes with the things that we already know about gravity, right? We know that as we're closer to the surface of the Earth, gravity is stronger. And as we're farther away, gravity is weaker. And so these places where you have stronger field lines, more field lines close together, more dense field lines, that means that the gravitational field is stronger. All right. Now, that is explaining gravitational forces using field theory. Now, you'll notice I've done the same thing for our other types of forces that we said could go by field theory. One is the electric force, right? An electric force, most of you are aware that we generally have 2 different types. We've got the positives, like our protons. Your protons have positive charge if you've been through chemistry. Your electrons have a negative charge, and you're comfortable with that idea that there are two different types of charges. We'll talk about that a little bit later on, but for now, just recognize that we got positive charges and negative charges. Now, in an electric field, remember with gravitational field, there was one type of mass. It was positive mass, and the field lines were always directly towards the object. In this case, because we have two different things, we have the positive and the negative, the field lines are a little bit different, okay? When we draw field lines for an electric field, it always tells us what's going to happen to a positive charge. And so I've got a positive charge here. We know it's positive because it's got a plus on it. It's also blue, and blue is a positive kind of color. So we go ahead and we put that positive here. If I put it here, we know that opposites attract and that like repel. Hopefully you've learned that at a previous time. If not, this is a great time to learn it. All right. But you can see the field line points from the positive to the negative. So if I put this guy here, he's going to follow along the field line until he gets to the negative, right? Anywhere I put this positive, he's going to go through basically that process. I can put him right here, and you can see the field line there goes right here. So he would go and it go right there. All right. So again, you can see how we're drawing these field lines, and we say, well, because there's a positive charge here, it's creating a field, right? It's creating a field of influence that it's able to, as soon as I put a particle there, it's being acted on by that field. All right. A negative particle, okay, negative particle will do exactly the opposite. These lines were showing what was happening to a positive charge. A negative charge would do exactly the opposite. If I put a negative charge right here, I see the field line is pointing this way, and so it will be pushed back along that direction in the opposite direction, because the field lines will always demonstrate what's happening to the positive charge. So again, this is just giving you an idea. We'll take lots of time drawing field lines and representing what happens and understanding what's going on here, but this is just to give you a little bit of an introduction as to what's happening. All right, notice again, much like our gravitational field lines, when I'm closer to the object, the field lines are closer together, which means I'm going to have a stronger force there. When I get close to this guy, the field lines are very strong over here, which means you're going to have a stronger force over here. In between, and this should kind of make sense, if I put my charge, my positive charge way out here, he's not really very close to either of them. Okay, but he is going to get pushed away from the positive a little bit, right? So he would be pushed away this way a little bit, and he'd be attracted towards the negative a little bit. So you can kind of see that he's got a little bit of push down and a little bit of pull up, and so he's going to kind of follow along. Similar to this line right here, he's going to follow along until eventually he ends up at the minus there, right? So again, just trying to get comfortable with this idea of fields. All right, the last one, again, magnetic fields, right? This is not something that we see, but we can draw lines to visualize it, right? So we draw lines. The magnetic field goes from north to south, all right? So it starts at north, it goes to south. And so when the way we usually read magnetic fields is by using a compass. So I got my high-tech compass here. We're going to go ahead and stick the compass on here. And when I stick the compass here, it's going to rotate like that, just like that. And you may say, well, isn't the red supposed to go to the North Pole? Yes, it is. But the North Pole is actually the South Pole magnet, which is a little bit weird. We'll talk about that a little bit more when we get to magnetic fields. But again, I want you just to recognize this idea that this field, this influence is here, but it doesn't actually do anything until an object is placed there. And as soon as the object is placed there, it will interact with the field and it will do what it's supposed to, just like your compass is going to turn to point towards the North Pole. All right. Same thing here. The field is here because I've got a charge. It has a field of influence. It doesn't do anything until I take my charge and I place it in that field. Once it's in that field, it's going to be influenced by the field. And because this one's positive, it's going to follow along basically in between those lines. All right. Same thing here. This field is here. That influence is there. And it's not going to do anything until I place another mass there, which is then going to follow the general direction of our field lines, which means it's going to be attracted there. All right. So hopefully that kind of makes sense a little bit. Hopefully you're being able to view how fields work. And they're very, very similar for all of these. Just recognizing what is the important thing for gravitational fields, mass, what's important for electric fields, charge, and what's important for magnetic fields, whether it's a north or south pole that we're working with. All right. So now you've got a basic introduction to field theory. What you're going to do next is you're actually going to look at Newton's law of gravitation. Now, remember, a law doesn't explain why it happens. So it's not proving whether field theory is correct or wrong. It's not proving whether Einstein's theory is correct or wrong. It's not proving whether gravitons are correct or wrong. All it's doing is it's saying what is happening when we have masses put together. So we're going to go ahead, we're going to start with gravitational, and we'll look at Newton's law of gravitation, what exactly happens when two masses get together. After that, we'll start to look at some of these other ones. All right, good luck, and move on to the next step.